So it's possible you're going to come across a problem like this in Newton, and I just wanted to go through one to make sure that you're comfortable and you've seen it before. It's always nice to have somebody else walk through these with you. So let's take a look at this one. Differentiate a composite of three functions. And this one, we're getting information from a table, okay? So remember, with the chain rule, we're going to take the derivative of the outside and work our way in, okay? So with that in mind, you can see right here, I've got k prime of x, and you'll notice I've got f prime, and then g of h of x, and then g prime h of x, and then h prime of x. So again, I'm taking the derivative and working my way from the outside in. So we're going to use this chart, and we're going to see if we can't figure out how do I take this derivative. So to find the derivative of k prime of 2, okay, k prime of 2, I've got this, and it's kind of jumbled. It's a little hard to see. Let me see if I can't make this look a little cleaner for you. F prime of g of h of 2, okay? And then we're going to multiply that by g prime of h of 2. And then we're going to multiply that by h prime of 2. Okay, so you can see as I've gone through and I've done this for you already. Okay, so h prime of 2 is 1. All right, here's what I'm going to do. I'm going to look at the h prime column, and I'm going to find the 2, right, the 2x value, and you can see h prime of 2 is 1. The next thing I have to do is identify, okay, well, what is h of 2? Okay, so here is the h column, and h of 2 is 3. Right, so I replace h of 2 with 3, so the g prime stays, and it's g prime of 3 now. And the same thing here, h of 2 is 3, so it's g of 3. Notice the notation there, okay? So working my way through, now I'm going to focus on g prime of 3. So g prime is here, and 3 is here. So g prime of 3 is 3, and we've got 3 times 1. G of 3 is 8, so I'm going to take the derivative of f when x is 8. F prime of 8, f prime of 8 is 4 times 3 times 1 equals 12. Okay, so if I ask you find the derivative of k of x equals secant to the third, x to the fourth plus 1, I'm going to start and work my way from the outside in. The hard part is figuring out what's the outside. So it turns out that if you rewrite this problem, you can rewrite it like this. Secant of x to the fourth plus 1 all to the third power. That's what the publisher's done here. Now I can work my way from the outside in. So it's 3 times secant x to the fourth plus 1 squared, right? But I've got to multiply that by the derivative of secant, which is secant x to the fourth plus 1 tangent x to the fourth plus 1. I don't need that parenthesis right there. One more thing to do is to go multiply by the derivative of x to the fourth plus 1, which is 4x to the third. And so I'm going to multiply the yellow, green, and red terms together. Notice 4 times 3 is 12x to the third. Secant to the third. So there's a secant to the second right here times a secant. That gives me that secant to the third. And then tangent. Here's one more chart problem, and we can take a look at this one if you like. There's a little bit of a difference right here with this negative h of x. So if I follow that formula that I did just a minute ago, I'm going to work from the outside in, okay? G of negative h of x. Okay. Now I'm going to multiply by the derivative of g prime, right, of negative h of x. And then I'm going to have this last one. And so the derivative of negative h of x is just going to be negative h prime, right, times negative h prime of x. Okay, so squeezing all that on that page. That's what we've done right here, and you can see it's broken down for you. F prime of g of negative h of 3 times g prime of negative h of 3 times negative h prime of 3. Again, we're using our table to get these values. So I can look, I like to start on the outside right here. H prime of 3, here's h prime and of 3 is negative 1. But notice there's a negative out front, right? So there's the negative 1. Then I'm going to do h of 3, right? So h of 3 is negative 2, but there's also a negative out in front of it. So I've got g prime of negative 2. And the same thing here, the derivative of g of negative 2. So this turns into g of 2, right? And this is g prime of 2. So g prime of 2 is a negative 5. I've got that negative 5 here. G of 2, here's g of 2. G of 2 is 3. So I'm going to take the derivative when x is 3. Here's f prime of 3, which is 0. And 0 times all that stuff is 0. The chain rule can be really, really intense. I hope you'll take the time to go through Newton and email me questions that you may have. I'd love to work through those with you, okay?